Okay, so today we are going to discuss what is meant by invariance principle, and before going to discussion of invariance principle, I will discuss it first. Probably it will consume two consecutive lectures. At first we'll discuss it in a very intuitive manner, then we'll discuss Bolzano-Weierstrass theorem, that is for sequence. And I wish I could discuss your what to say that the concept of Banach space, which you can find it very helpful here, but due to time constraint it is not possible for me to discuss it here now. Unfortunately, we sometimes even we do not have such intention, but we need to cut our coat according to clothes, so that is why I couldn't discuss Banach space anyway. So what is the basic idea of your invariance principle? So in order to understand that, we must need to understand that what is an invariant set, and then we will discuss further on this. So in case of in your invariance set, if you recall the example of mass spring damper system with that state model, like I am taking the linear one, the most like harmless and very gentleman kind of thing. So linear one, it was like now here one thing is very clear, and you can understand that if we apply if we define v in this way, like v is equal to half x transpose x, and we find out v dot from here, eventually we will reach a condition like v dot is equal to minus b x2 square. Now in this connection, if you find it, then apparently v dot is just a like a negative semi-definite function, but uh, however we will find it that v dot x is negative definite everywhere except on your horizontal line on which you are having x2 is equal to 0. So if we can means exclude that, or even exclusion, complete exclusion is not possible, then if we can think that or if we can project it in this way that x2 for any non-zero value of x1, x2 cannot identically be equal to 0, then with that we can prove that x2 cannot stay there in that state, like where you are having x1 some finite non-zero value and x2 0. So typically I am talking about some point on your horizontal line or on x1 axis where your x2 is equal to 0, but x1 is not is equal to 0 except at origin. At origin you are having x1 is equal to 0, x2 is equal to 0, fine, no issue. But for all other places we will be able to show that x2 dot is not identically equal to 0, and therefore whenever it becomes 0 momentarily, then it again crosses. I think I have discussed this, and you should be not be that naive to explain it once again here, because we are running out of time. Now what is the issue here is that like vxt, that is going to so what means the idea what we can draw from here is that we can consider a domain of the origin where we can find the Lyapunov function, rather the derivative of Lyapunov function, along the system trajectories is negative semi-definite. Because if you draw its phase portrait, what you will get something like a spiral. And for typically you start with x1 some non-zero value, say x1 is equal to x1 0 and x2 is equal to 0. This is your initial condition at t is equal to 0, and then this forms a spiral like this. And all these points of intersection, including this one also, you will find that everywhere x2 is equal to 0, but x2 is not identically equal to 0. So therefore there is a oscillation, there is a means like what to say, departure of your trajectory from that point. uh, After arrival, it as soon as it arrives, departs also from that one. So that is just a very means the motion is there in uh, transitional, not means it is not stationary. Like once it sorry, I have to receive a call. So actually people loves me very much. That is why they call me every time. Uh, so that is a bit problematic also, because it sometimes disturb my flow. Now see here that like we can find out like the other than the origin, all other points they are means the even if the trajectory reaches those points where your v dot is 0, but they cannot stay there for means stay there for a long while. They had to leave. So that is what we know that this if we try to formalize it. Now one more thing I would like to state here, that if you recall that limit cycle or whatever, actually I also invited Dr. Maiti to talk more on that, but sir was so involved in that his research, he started delivering lecture to a means to some advanced level. So perhaps many of you found it quite difficult to understand. Anyway, limit cycle, we can, even if you forget about limit cycle, think about like if you have or okay, limit cycle will be means a good example. I'm not going to draw it or means making this space clumsy. You can hit Google and Wikipedia or whatever. You will get plenty of resources on limit cycle, and just I need the brief intuitive idea. You'll see for a stable limit cycle what is happening in case of a stable limit cycle. If you start from anywhere on your state space, eventually you will reach means your trajectory, not you, rather your trajectory will reach to that limit cycle, and it will stay there for infinite time. But a limit cycle, unlike this problem, here origin is your equilibrium. Limit cycle, it's not a point, it's a cycle. In your phase plane means it's a complete, like you can have different value of x1 x2 altogether on that one, but still on that it is there. So what we can see or say that this idea follows from a principle that is known as that is attributed to famous scientist Lashley. We call it Lashley's invariance theorem. Now in order to introduce that definition or anything, we first understand a few definition. Like again we are considering that autonomous system x dot is equal to f of x. Now here a point capital P is said to be, just a minute. So a point P is said to be a positive limit point of xt if there is a sequence, better to write if there exists a sequence Tn with Tn tends to infinity as n tends to infinity. So here the basic thing is very clear, like instead of taking continuous time, if you think about having a sample time, so even if you consider a very small sampling interval, but for any finite non-zero interval where your sample is difference between two consecutive sampling is something greater than 0, then obviously if you increase the sampling time to infinity, then obviously there will be the total time that will be described by all those sampling instants, that is Tn, will also become infinity. Now we have such that x of Tn tends to P as and the set of all positive limit point of xt is called the positive limit set of xt. Now a set capital M is said to be an invariant set, for the autonomous system x dot is equal to f of x if again we have reached the end of the paper, pages like x0 belongs to M implies xt belongs to M for all t belongs to R. Sorry, all t. Sorry. So this is the very simple thing. What we are trying to say that, like a set m, like means literally stated, if your initial point is in m, the final point will also be in m. Like if we go back to that epsilon delta, that if the set is epsilon, the radius, or means the region defined by that radius epsilon, if that is an invariant set, or that, sorry, the region defined by the radius delta is an invariant set, then the trajectory will start delta will also remain in delta, it will not go anywhere, right? So what is the, means how to utilize the concept of positive limit point and positive limit set for xt in this means in this context of invariant set? The reason is like, we can say xt approaches m as t approaches infinity if for each epsilon greater than 0 there exists capital T greater than 0 such that where this is the smallest distance so this is the distance, like what I'm trying to say, like the smallest distance we can define using the notion of infimum. Like if p, you know the p is the positive limit point, then you can have this so here this one, like this distance from a point p to set m, that is the smallest distance from p to point m is infimum, that I have means written. Now like that the how to make you understand, like why we need this, like we can have two things, as I mentioned, that we can have either a stable equilibrium point or we can have a stable limit cycle, right? So if you think your system is locally asymptotically stable, then within the region in which your system exhibit that local asymptotic stability will act as an invariant set. Now instead of wasting time here, I would like to discuss a theorem, and that theorem, not theorem, rather a lemma, and that lemma itself will be powerful. When you will find that lemma powerful enough to proceed with the further mathematical discussion on this topic. So here let us just go there. Like if a solution xt of x dot is equal to fx is bounded and for all t greater than is equal to 0, then its positive limit set L plus is non-empty compact and invariant set. Moreover, right? So, what is the D? D is the domain where we define everything we know about D. Now, let us try to prove this lemma. Okay, just let me check. No, let us cut this whole thing to our next page, otherwise again so before I discuss the proof of this lemma, let me talk about this concise discussion on Bolzano Weierstrass theorem. This is related to sequence of real number, but before that we must understand that what is a bounded sequence. I have already discussed that Cauchy and convergent sequence. Like if you consider let me give you one example, like like I think I have discussed all this. If you have problem, you can come back to me. But let me, without wasting time, let me directly go to the statement of Bolzano-Weierstrass theorem. I think you have a clear understanding on the concept of bounded sequence. So what Bolzano-Weierstrass theorem states that every bounded sequence in Rn has a convergent subsequence. We can prove this one in three different way, but we will not consider a single one. Rather, we will just use this statement to understand our own lemma that I just have written here, that if a solution is bounded and belongs to D for t greater than 0, then its positive limit set L plus is non-empty and compact and invariant set. Moreover, xt approaches that positive limit set as t tends to infinity. So we'll try to understand that. So here, if you note that since xt is bounded, so by application of Bolzano-Weierstrass theorem, we can understand that it has an accumulation point as t tends to infinity, and hence that accumulation point bounded and belongs to D, so that accumulation point must also belongs to D. So L plus at least have one point. It may have more than one point, like in case of your limit cycle it can have more than one point, but at least one point will be there, right? Now so let me write it, otherwise we will not get it properly. That Bolzano-Weierstrass theorem it has an accumulation point so like why we are claiming that, like what your Bolzano-Weierstrass theorem said, like every bounded sequence in Rn has a convergent subsequence. So if you break it in small pieces, then you will like here, if you just break this total xt in different segment, then xt gradually move to where xt like L is non-empty, means we have to prove that the positive limit set L plus is non-empty, compact and invariant set. So what is the definition of L plus? For our reference, let us quickly revisit the concept of L plus. Yeah, so this is limit set limit point of xt if there exists a sequence tn with tn tends to infinity as n tends to infinity, such that xtn tends to p as n tends to infinity. The set of all positive limit points of xt, like collection of all such t, is called the positive limit set of xt. Actually, I forgot to mention here, this is actually the L plus, right? So if you consider that L plus, now if your xtn is bounded, that means it will obviously converge to a point, right? Now if that is convergent, now why we need Bolzano-Weierstrass theorem? Like you are breaking it in pieces, and somewhere when you will take the means subsequence that is very close to your means, although it is an if you consider it's an means there are infinite member in the sequence, it is very close where your means n is close to infinity, then they are already that the value xt, like t tends to infinity but the value xt tends to p. So if you have if you think about that sequence comprises of all xt, then if you Like if you are not able to visualize it, let me help you. You take one RC circuit, right, or RL circuit, and you just give an impulse, and then you observe the response, and then that response, if that response is your xt, then you plot it with respect to time. So what would happen? Suppose you are having one charge capacitor uh, in combination with a series resistor, and then you just short it, right? So what would happen? The capacitor voltage gradually discharge through that resistor, right? So gradually that capacitor voltage will become zero, but so it will means converge to your that 0 point. So 0 will be your that point P. Now here what we are saying that if you take means wait it for infinite time, then obviously after that it will convert to 0. Now you are just trying to sample it, right? So if you sample it, you will have infinite number of points, say even for a finite sampling interval, say uh, means you take one sample at t is equal to 0, another one at t is equal to 0.1, next one at t is equal to 0.2. So you will have infinite number of sample point with respect to time. You are getting collecting xt, all these xt you have collected. So now this is a sequence that is bounded. Now this bounded like every bounded sequence in Rn has a convergent subsequence. So if that has a convergent subsequence, so you will have that towards tail, you will have that convergent one, and by that you can say that your L plus is non-empty, because that is the point P where your set will try, sorry, the solution or xt will try to converge, right? Now what we can say, like L plus is non-empty. Now for each, say, we can write for each with ti tending infinite as I tends to infinite, such that xti tends to p as I tends to infinite. So now since your sorry xti is bounded, then what we can conclude, that xti is bounded uniformly in I, that therefore p is a p is bounded, and p, all such p is present, only all such p is present in L plus. Therefore L plus is bounded, right? Now last one, what is there? Non-empty compact, and means compact, for showing that it is compact we need to show it's bounded and closed. So we have to prove that L plus is also closed. So how can we prove L plus is closed? To prove that L plus is closed, let us consider be some sequence such that your this pi tends to p as I tends to infinity, and with this we can prove that we need to prove that p belongs to L plus. So for every I, uh, let us consider a sequence sorry. So this is how we define this pi. Like we are having Tij, where it is like uh, you are having multiple such points and multiple solutions, and all these points you are getting for uh, like for ith solution there is a time variation Tij that is going to infinite, and then you are having the point pi for that ith solution. Now what we can see that we will be able to construct a particular sequence tau I such that given the sequence right, and such that now similarly, sorry, is 1 by m, Instead of selecting m, you can select 2 3. That will make it easier to understand. Like oh God. Similarly, you can select tau 3 greater than t1 3, such that x of tau 3 minus p3 less than 1 upon 3. And accordingly, like half and 1/3, you can have I is equal to 2 4 5 3 sorry 2 3 4 5, like this. So gradually you will have tau I tends to infinity as I tends to infinity, and the beautiful thing is, okay, so given, see the beauty that I is coming to your denominator. So given epsilon greater than 0, there are positive integer in 1 and in 2, such that so we are having these two. So the first inequality, from where you can get this first inequality from here, and the second one is that we have defined it in such a way that pi tends to p as I tends to infinity. So from this it is clear that we can have such integers for which we get this, and then we can write like combining these two, for all I greater than n is equal to maximum of these two integers. So this clearly shows that xti tends to p as your t tends to infinity. Hence your L plus is closed. Closed in the sense like you are having the limit point, like if you forget what is a closed interval or closed set, forget about topology and all other things. So when we can write it in a closed bracket format like 0, 1, that means both 0 and 1 are included here, and they are the terminating point for that set. So similarly here L plus, as L plus contains P and all other point, so therefore L plus is closed. So already we have proved that L plus is bounded. Now we have proved L plus is closed. Therefore L plus is compact. Right? Now we have to show that L plus is an invariant set. So to show that L plus is an invariant set, let us consider P belongs to L plus and phi T P be the solution of x dot is equal to x that passes through P at t is equal to 0. So basically we try to say that phi 0 comma p is equal to p, and from that we want to show that phi t sorry now let us consider a sequence ti where ti tends to infinity as I tends to infinity, such that we write I hope you know that this is the standard form of representation of solution for linear system, or even in case of nonlinear system also. If you know the solution, then you can always write it in this way. Now, like so, where xt at t is equal to 0, so now by uniqueness of the solution, like we are already assumed that on D we are dealing with D where your x dot is equal to fx is Lipschitz with respect to x in the domain D. So we can apply the uniqueness of the solution and apply that the and which results right. So for sufficiently large I, we will have our limit I tends to infinity phi t plus ti and what is this? This would be. So this follows that and which is the definition of the invariant set, right? So we have shown all the things. Now only one thing remaining, that all the xt will tends to this L plus as t tends to infinity. That we can show by like contradiction, that it is not true, then there will exist and prove by contradiction. If it is not true, then we'll have some epsilon greater than 0 such that a sequence will have a sequence ti with ti tends to infinity as I tends to infinity. However, where we will apply the that distance of xt your, if we consider that L plus. Now here actually you are measuring xt and it's a set, so means some, you might have some confusion that how to measure the distance of any point from a set. So I'll help you. If you have that confusion, if you really interested to know, then come back to me. Otherwise there is no point. It means you just assume that the things are. So this is clearly a contradiction. Now the sequence xti is however a bounded sequence. If it is bounded, oh god, xti is bounded. So if it is bounded, then what happens to a bounded sequence? If we increase that ti, the bounded sequence will converge to somewhere. Like bounded sequence will I always make this mistake. X is a vector, so we should use capital letter, not small x, right? They will converge to some x star. So if that is the case, then this point x star must belong to L plus x star must belongs to L plus. However, we are claiming that this distance is greater than epsilon, so that is a contradiction. So in other way we can say that xt will always converge to your L plus. So So this is the basic lemma. Based on this, we'll in our next video we'll discuss that how to means we discuss the invariance principle for our nonlinear system, right? So we'll discuss a very important theorem in our next video, that is Larshally invariant theorem. If you are not able to like comfortable with this lemma, still it will be acceptable. Although I hope I have given all the explanation except how to measure the distance of a point from a set, that I have not yet mentioned. But I hope that many of you should actually you can find out the answer by yourself. What I told you in other videos, that please, whenever some question comes in your mind, hit Google. You people are doing master degree, and it is expected from master degree student that they should find the you are going to be a master of this particular discipline. So you should find out the answer by yourself and just cross verify it with your teacher. Not like you have no clue about the answer and you are just asking the teacher for the answer. It should not be the case. Rather, you should have a concrete argument, or you should have or rather I encourage that you people come up with, like on this semester, I know it's quite a hectic schedule for you, but I wish that in next semester onwards we'll have a very engaging debate session. Like I'll give you a topic and interested student will form a debate club where we'll discuss and debate on topics of control system engineering, right? So in the next video I'll discuss Larshally invariance theorem.